Welcome to ClickMyProject.com. The title of the project is Prediction of Malignant Breast Cancer Cases Using Ensemble Machine Learning, a case study of pesticides prone area. And the abstract of the project is the foremost often occurring cancer after lung cancer is breast cancer. Breast cancer is the second most frequent causes of fatality in each developed and undeveloped world. Breast cancer is characterized by the mutation of genes, constant pain, changes within the size, color, skin structure of breast. Classification of breast cancer leads pathologists to search out a scientific and objective prognostic. Usually the foremost frequent classification in binary, benign cancer or malignant cancer. Today, machine learning techniques are being broadly speaking utilized in the breast cancer classification issue. They lay out his classification accuracy and effective diagnostic capabilities. In this process, we are going to train the breast cancer histopathological images by using machine learning. We propose the machine learning models like XGBoost classifier, support vector machine classifier, and random forest classifier. The K-fold cross-validation was implemented and generated different cross-validation results. Finally, the three algorithms are ensembled with voting classifier to train the dataset and generate the results in the form of metrics like accuracy, precision, recall, FN score, Mathew correlation coefficient, specificity, and ROC accuracy. And the flow diagram of the project is, first we need to start the program and select the histopathological breast cancer digital images, and we use the sample images in our console working directory. After that, we are going to resize all the images and convert it into flatten, then it will make it as a data frame. So by the data frame, we are going to select our independent variable and dependent variable. After selecting the independent and dependent variable, we are going to split our model into train dataset and test dataset. Then it will implemented into machine learning classifier. In machine learning, we are using three different types of classifier like XGBoost algorithm, support vector machine algorithm, and random forest algorithm. Those three algorithms are train the images individually, and also it's ensembled with the voting classifier, then generate the results in the form of matrices like accuracy, precision, recall, FN score, and AUC accuracy. So the program was successfully executed in Anaconda Navigator Spider IDE. So these are the result of breast cancer classification. So this is the sample image visualization of benign and malignant classes from the breast cancer images. So after that, I have to check the minimum height, minimum width, maximum height, and maximum width for every classes in our dataset. So after that, it will play into pre-processing. In pre-processing, I'm going to resize all the images and flatten the images and then converted into data frame. So this is the input data frame of our process. So by that data set, we are going to select our model like the independent variable and dependent variable. So the features of the images are all the independent variable and the target is our dependent variable. So after selecting independent and dependent variable, we are going to split our data set into training data set and testing data set. So training data set contains majority of data and testing data set contains only minority of data. So after that, it will move into classification. Classification, you are using three different types of machine learning algorithms like XGBoost machine learning algorithm and support vector machine learning algorithm and random forest machine learning algorithm. So the XGBoost machine learning algorithm accuracy is 87%. So the cross validation mean average score of XGBoost algorithm is 87%. So this is the classification report for benign and malignant classes for the XGBoost algorithm. So the precision is number of correct prediction and recall means number of correct instances of prediction, and F1 score means to measure the test accuracy for the benign and malignant classes in XGBoost algorithm. So this is the confusion matrix for our XGBoost algorithm. The confusion matrix which is going to explain the number of correct prediction and misclassification from the XGBoost classifier. So this is the specificity of our XGBoost classifier is 93%. So the Mathew correlation coefficient score of our XGBoost algorithm is 0.59. So this is the learning curve for our XGBoost algorithm. The learning curve which is explained the training score and the test score, that means class validation score. So this is the confusion matrix diagram. So the ROC accuracy of our XGBoost algorithm is 92.5%. This is the ROC learning curve. So our second algorithm is support vector machine algorithm. The support vector machine algorithm achieves 84% of accuracy, and the cross validation score mean value of support vector machine is 86%. So these are the classification report for our support vector machine algorithm, and this is the confusion matrix for our support vector machine algorithm. So the specificity of our support vector machine algorithm is 88%, and the Mathew correlation coefficient score is 0.55. So this is the learning curve for our support vector machine algorithm. So this is the confusion matrix diagram, and the ROC accuracy of our support vector machine is 90%, and this is the learning curve for ROC accuracy. So our final machine learning algorithm is random forest algorithm. The random forest algorithm, which is achieves the accuracy rate is 89%, and the cross validation score for mean value of random forest is 88%, and these are really the classification report and confusion matrix. The random forest specificity is 0.96. So the Mathew correlation coefficient score of random forest algorithm is 0.64, and this is the learning curve for random forest algorithm, and this is the confusion matrix for random forest algorithm. And the ROC accuracy of random forest algorithm is 93%, and this is the learning part of ROC accuracy of random forest algorithm. And finally, the three individual algorithms are ensemble with the voting classifier and to find the majority votings. So the voting classifier accuracy is 87%, and the full cross validation of our voting classifier mean value is 87%. Finally, the prediction was made by the XGBoost algorithm. So the user can manually choose the images from our dataset directory, and then they can predict the probability of our input images and predictor labels. So the predictor images is malignant, and the probability of the malignant images is 99%. So these are all the variables that we are used in our program.